all, this is Sahiti on behalf of Edureka, and I welcome you to this session on Microservices Tools. So in this session, guys, we'll focus on the different tools that you can use to manage your services. Alright, so without wasting any further time, let's take a look at the topics for today's session. So we'll start today's session by understanding what are microservices, and then I'll discuss different tools used in microservices based on various parameters, or you can understand as used for different stuff. Right? For example, I'll start with different operating systems using which you can build your services. Then I'll talk about the different programming languages you can use to build microservices. Once I'm done with that, I'll talk about the tools for API management and testing, the tools for messaging, the different toolkits available in the market. After that, I'll talk about the different architectural frameworks, the tool for orchestrations, the tools for monitoring, and finally the serverless tools. So on that note, let's get started with today's session. So on that note, let's start with the first topic for today's session, that is, what are microservices? Microservices, or most commonly known as microservice architecture, is an architectural style that structures an application as a collection of small autonomous services modeled around a business domain. So you can just understand microservices as small individual services communicating with each other around a single business logic. For example, let's say you have an e-commerce application. Now that e-commerce application can have different functionalities like the customers, the customer details, the product details, and maybe what orders that you've ordered, right? So what you can do is when you build this e-commerce application using the microservice architecture, you can divide these three functionalities into three different services known as the customer service, the product service, and the order service. So once you build these three services will communicate with each other with the help of the messaging system that microservices have and give the user the required outputs, right? So if you want a detailed understanding of how microservices are built and how you can use them, so you can refer to our session on microservices using Spring Boot, right? Since this session is completely based on microservices tools, I'll focus on the tools more. So on that note, let's get into the main topic for today's session, that is microservices tools. Now, if you ask me what are microservices, my answer would be really simple. Microservices tools are basically a collection of various tools and technologies having different functionalities. These tools are used in various stages of building an application and help the developer to work with ease. Alright, so they come with basically predefined functions, algorithms, and a very user-friendly GUI to make sure that developers can build their applications in an easy manner. Not only this, but startups to multinational companies have been using microservices in their day-to-day business activities today, and to make sure that they can build the application in an easy way, many other companies are building up new tools and technologies, right? So while building an application using microservices, I would not say that only a single tool is enough. Maybe I would say a couple of tools together will help you build the application in a more easy way. So on that note, let's look into the different tools that we can use for different purposes. So starting with the first one, that is operating system. Now, one of the most important factors of building an application is setting a proper foundation of your application. So this is basically done by the operating system. Now, Linux is one such operating system which is most commonly used in today's market to build applications. With the help of Linux containers, it provides a self-contained execution environment and lets you orchestrate small to big services like security, networking, and storage. So if you ask me what are the better choices of Linux family, then I would say Red Hat and Ubuntu are the go-to solutions for anybody in today's market, but they come with a lot of unnecessary functionalities which are not needed for microservices. Apart from these, Linux providers have also come up with tools such as Atomic Red Hat and Ubuntu, including LXD, which is basically a container-oriented hypervisor. So I would say that you can go for any operating system that your company chooses to build an application or maybe you're comfortable with. But Linux is one such operating system which is growing in today's market and helps the developers to build the applications easily. Now, let's move forward with the next one, that is programming languages. Now, the main advantage of microservices is that different languages and technologies can be used to build different services of the same application. So what I mean by that is, let's say you have 5 services in the same application. Now, the first service can be built using Python. The second one can be built using Java, the third one can be built using Go programming language, and so on. So it basically gives the developers the freedom to choose the technology stack and build the application. But the most popular programming languages used in microservices are Spring Boot and Elixir. So talking about Spring Boot first, Spring Boot basically simplifies the creation of REST-based microservices with the help of Spring Boot frameworks in just a few lines of code. right? So if you ask me the features of Spring Boot, then it provides auto configuration to load a set of default configurations for quick start of the applications. It comes with embedded Tomcat, servlet containers, and Jetty to avoid the usage of WAR files. Spring Boot also has an opinion to reduce the developer effort and simplifies the Maven configuration. And finally, it consists of a wide range of APIs for monitoring and managing applications in the development side and also on the production side. So Spring Boot is one such programming language, guys, which is very famous in the field of microservices. And you would always see that, developers are trying to build microservices using this particular framework. All right, so that was about Spring Boot. Next, let's move forward with the next programming language, that is 𝐿𝐿𝑥ia. Now, 𝐿𝐿𝑥ia is a general purpose programming language which runs on the Erlang virtual machine. Now, 𝐿𝐿𝑥ia shares the same abstractions for building fault-tolerant and distributed applications. So if you want me to mention a few features of 𝐿𝐿𝑥ia, then I would say developers can easily write the code in short, fast, and maintainable manner. This code basically runs in isolated lightweight processes which can be scaled individually. For example, let's say you have 5 processes, right? And you don't want to scale a particular process, but you want to scale up the other processes. Well, you can definitely do that. Apart from this, 𝐿𝐿𝑥ia also makes sure that the application never goes down by providing the supervisors. So basically, these supervisors describe how different parts of the system can be restarted if something goes wrong. And that is the main objective of microservices, right? So our main objective is basically that, even if a particular service has gone down, that doesn't mean that, the application will go down. Instead, the bug in that particular service has to be resolved and then the service has to be restarted. And finally, coming to the last feature, that this programming language comes with its own build tools to create projects, manage tasks, and run the required tests. So guys, these were the 2 programming languages which are very popular in the field of microservices. Next in this session, let's look into the different tools used for API management and testing. Now, while you start building applications using microservices, you also have to make sure that all the individual services communicate with each other using APIs. So each microservice can have its own API to communicate with the other service. So this is where basically the API management and testing comes into the picture, where all the APIs are present in the system and must be properly managed and tested to get the desired results. So if you want to know more about microservices and APIs and how APIs and microservices collaborate with each other, you can refer to my session on microservices versus API. Now, the top tools used in API management and testing are basically the Postman and the API Fortress. So starting with Postman. So Postman is basically an API development suite which allows you to easily run UI-driven API tests. With the help of Postman, the exploration of RESTful API resources becomes very easy. So what I mean by that is that, with the help of Postman, you can basically pass HTTP requests to test, develop, and get the required results. Now, few features of Postman are as you can see on my screen. Postman basically integrates with your software development lifecycle in ease. It provides features to design APIs and maintain multiple versions of API with support. This tool can work for small applications to big application, and it also supports collaboration of work by allowing you to save related API endpoints into a collection. Now, once that is done, what you can do is you can go forward and share the entire collection to the other developers. So guys, these are the few features of Postman. Next, let's move forward with the next tool, that is API Fortress. Now, API Fortress is both an API test and health tool which automates the process of load testing, health monitoring, and functional testing. This tool is basically a code-free and is built around modern API architectural patterns and practices. So if I have to mention a few features of API Fortress for you, then this tool is highly interoperable with any platform that you choose in your toolchain and validates APIs built in API management platforms. It also simplifies API test creation and execution by providing a drag-and-drop GUI. This tool also aims to simplify the end-to-end testing by providing easy generation of functional tests, and also focuses to simplify the collaboration by storing the tests and reports in a collaborative environment to make sure that teams can validate their own APIs if it satisfies the business case. So guys, these were the few features of API Fortress. Now, once you know the tools for API management and testing, the next thing that comes into a microservice system is basically how these services communicate with each other. Well, these services communicate with each other using the messaging system. So the different tools available for messaging are Apache Kafka and RabbitMQ. So talking about Apache Kafka first. This tool is a distributed publish-subscribe messaging system originally developed at LinkedIn and later on became a part of the Apache project. Kafka is scalable and agile and is distributed by design. So Apache Kafka is a distributed stream processing platform which can be used for data processing or API calls. So few features of Apache Kafka are as you can see on my screen. Kafka has high throughput for publishing and subscribing messages to maintain stable performance. This tool guarantees zero downtime and zero data loss. In Apache Kafka, messages persist on the disk as fast as possible, and many applications can plug in and make use of this tool as it offers new write connectors. So guys, these are the various features of Kafka. Let's move forward with the next tool, that is RabbitMQ. Now this tool utilizes patterns to communicate between microservices and also scale applications simultaneously. With the help of these tools, you can basically connect microservices with each other to solve problems of various distributed systems. Not only this, but you can also use this tool to exchange events between individual microservices. Now the features of RabbitMQ are as you can see on my screen. This tool basically offers a variety of features such as reliability, delivery acknowledgements, including persistence, publisher confirms, and higher availability. By using this tool, messages are routed through exchanges before arriving at the queues. RabbitMQ comes with the federation model and allows the servers that need to be more loosely and unreliably connected, and also supports messaging over multiple messaging protocols. So guys, these were few features of RabbitMQ. Now, once you're done with your API management and messaging, the next thing is basically that comes onto everybody's mind is toolkits. What do you understand by toolkits? Well, toolkits in layman terms is a set of tools used for a specific purpose. So in microservice architecture also, you can build various kinds of applications using different toolkits that are available in the market. So the most popular toolkits available in the market are Fabric 8 and Seneca. So talking about Fabric 8 first. So Fabric 8 is a platform as service tool which helps the developers provide configuration management system through Git. It is an open source tool which handles port mapping and IP addresses complexity. So this tool basically holds the responsibility to load balance services with high availability and scalability. Now the features of this tool are as you can see on my screen. It provides a set of wizards to create application faster and set up continuous delivery pipelines. Fabric 8 also comes with on-premise Git repository hosting. This tool provides Maven Repository Manager, promoted releases, along with a mirror of central Maven repositories, and provides the developer console to create, build, manage microservices with deep visualization into the projects, applications, and environments. Now talking about Seneca first. Seneca is used for building message-based microservices processes and is the toolkit for Node.js. So this toolkit helps you to write clean and organized code with systematic business logic of the application. So a few features of Seneca are as you can see on my screen. Seneca provides plugins which look after the foundation of the application. You do not have to worry about which database has to be used and how to structure your components with Seneca. In Seneca, everything is written as a command, and these commands get called whenever they match a set of properties, and the code that you call does not know which command is calling it. So guys, this was all about Seneca. Now, since you've understood about toolkits also, the next thing that I would like to talk about is the different architectural frameworks. So architectural framework is an important factor while building applications using microservices, and the top two architectural frameworks used are Goa and Kong. Talking about Goa first. So basically, Goa is an architectural framework which provides a way to build REST APIs and microservices using Golang. With the help of this architectural framework, you can design APIs along with its required dependencies, and this framework runs on top of the Google Cloud platform. Few features of Goa are as you can see on my screen. This tool also lets you generate data structures, validation of code, and handlers once the design of API is set. It has a decoupled engine and provides plugins which can implement custom DSLLs and also generate arbitrary outputs. So that was about Goa, guys. Moving on to Kong. Kong is used for ready-to-deploy plugins for enhancing the development and deployment of microservices. With the help of this tool, you can leverage the container and microservices design patterns to quickly build API-centric applications. Now, I've used this term microservices design patterns, right? So if you have to understand this term, it's basically a pattern, or you can say a software pattern through which a company follows based on which the application is built. So if you want to know more about microservices design pattern, you can refer to my session on microservices design pattern. But until then, moving back to this particular session, if you ask me the features of Kong, then Kong provides plugins to extend and connect services across hybrid and multi-cloud environments. It analyzes real-time data and leverages ecosystems to deploy Kong with Kubernetes. Kong connects with automation tools to improve efficiency and reduce errors. and provides role-based access control and encrypts end-to-end to comply with the industry regulations. So guys, that was about the different architectural frameworks present in the world of microservices. Now, once you build an application using microservices, the next thing that comes into our mind is to how to scale the application. Well, to scale this application, you have to use an orchestration system, as microservices work with respect to containers, and so container orchestration becomes an important aspect that has to be considered. So in today's market, there are various tools regarding the container orchestration for microservices, but the top tools available in today's market are Kubernetes and Istio. So talking about Kubernetes first, Kubernetes is an open source container management, or you can understand as an orchestration tool. This tool basically owns the responsibilities of container deployment, scaling and descaling of containers, and container load balancing. So if you ask me a few features of Kubernetes, then I would say Kubernetes can help you to deploy and update secrets and application configuration without rebuilding your image and without exposing secrets in your stack configuration. In addition to managing services, Kubernetes can also manage your batch and CI workloads, thus replacing containers that fail if desired. Not only this, but Kubernetes only needs one command to scale up the containers or to scale them down whenever you're using CLI. Else, scaling can also be done by using the Kubernetes dashboard, right? So if you want to know about dashboard also, you can refer to my session on Kubernetes dashboard. And finally, coming to the last feature, that is with Kubernetes, you can mount the storage system of your choice. What I mean by that is that you can either opt for a local storage or choose a public cloud provider like GCP or AWS, or perhaps use a shared network storage system like NFS or ISCSI. So that was about Kubernetes, guys. Let's move forward with the next tool, that is Istio. Now this tool supports service deployment on Kubernetes. So it basically provides features for manageability, security, and reliability to microservices communication. Now if you ask me how is it done, well, the answer is quite simple. It is basically done by the service mesh technology, which allows you to improve the relationships and interactions between applications and microservices. So few features of Istio are, as you can see on my screen. It performs automatic tracing, monitoring, and logging of the services. This tool automatically secures services to manage authorization, authentication, and encryption of communication between services. It also controls the flow of traffic and API calls between services, conducts a range of tests, and upgrades with red or black deployments. And finally, also applies policies and ensures that they're enforced and resources are fairly distributed among the consumers. So that was about Istio, guys. Now, once API management is done, messaging system is done, and then you have your tools for orchestration also, the next thing is to monitor your application. So to monitor your application, the top tools that can be used is Prometheus and Logstash. So talk about Prometheus first. Prometheus is a monitoring tool which basically allows visualizing monitoring information and supports time-based tracking for anomalous patterns which have to be detected. Also, this is an open source tool which basically gathers monitoring information. So the features for Prometheus are, as you can see on my screen. It provides a flexible query language. It comes with distributed storage and single server nodes which are autonomous. It discovers targets via service discovery or static configuration and provides dashboarding and graphing support. Now talking about the next monitoring tool, that is Logstash. Logstash is also an open source tool through which you can check the logs. This tool basically lets you stash, centralize, and transform data. So the features of Logstash are, as you can see on my screen. It supports a variety of inputs which pull in events from a multitude of common sources all at the same time. This tool aims to transform and prepare data regardless of its complexity. It also allows you to choose your own stash and transport data. And finally, it is a pluggable framework consisting over 200 plugins to create and configure a pipeline as you want. So that was about Logstash, guys. Now finally, moving on to the last part of today's session, that is serverless tools. Now these tools are a part of microservices which optimize the methodology of breaking stuff into small functions. So few serverless tools that are very popular are Claudia.js and AWS Lambda. Talking about Claudia first. Claudia is a serverless tool used for deployments for AWS Lambda and API Gateway. This tool automates error-prone deployments and configuration tasks and also contains tools such as Claudia Bot Builder and Claudia API Builder. So features of Claudia are, as you can see on my screen. It lets you deploy and update using a single command. It reduces the boilerplate code. With the help of this tool, you can also manage multiple versions and you can use standard NPM packages and do not have to learn Swagger. So that was about Claudia. Now moving forward to the last tool, that is AWS Lambda. AWS Lambda is basically a tool which provides infrastructure-less servers for your microservices builds, and the user is charged based on the pay-per-usage rate. This tool can be used in combination with the AWS API Gateway to host a REST API service, and with the help of this, you can serve any request made by the users. So if you ask me a few features of AWS Lambda, then I would say this tool enables you to run your code in response to the events and automatically manage the dependent compute resources. It lets you run the code without managing the service, so it pays as you use the service and you only pay for the compute time consumed. This tool scales an application automatically by running a code for each trigger. And finally, I would say this tool can be used to build a serverless backend for processing mobile API and web requests. So guys, this was all about AWS Lambda. I hope you've understood all the tools that I discussed here. So this was just a short introduction to all these tools. So if you want a detailed understanding of many of these tools, then you can refer to our Edureka channel, or you can comment down in the comment section with your doubts and we'll reply to you as soon as possible. Until then, this is all from my side today. I hope you found this session informative. So thank you and have a great day.